This is a practice exercise video solution. For this practice exercise, we'll begin with the supplied dataset swingarm-pe.f3d. We want to explore a linear static stress study for this generative outcome, so we're going to navigate to the simulation workspace. And notice that generative design inputs are available. We're going to select Yes to create a new study using those inputs. Because of this, we automatically have a study that's ready to solve. But with generative outcomes, it's always a good idea for us to generate the mesh first to ensure that we don't have any problems by right-clicking on the mesh and selecting Generate. You can see here that we do have a good mesh result, so we can solve the simulation study. This can be done on the cloud for 5 cloud credits or locally. We're going to solve ours on the cloud, and then we'll check back in once we have results. Now that we have simulation results, let's take a look. We can see here that the actual safety factor is going to be 1.72, but that doesn't tell the whole story. That safety factor is based on load cases. We can look at all the different load cases and see what the minimum safety factor is for each of these. We can also take a look at things like the stress or displacement on the swing arm. Reviewing all of these will help us identify if the swing arm will meet our specifications or if adjustments need to be made. If we take a look at the safety factor and we look at, for example, load case 1, which is max compression, we can see that the minimum safety factor is in this area, and to better identify that, we can use the color bar to focus our attention on all areas that are at or below. If we take a look at this, it is essentially a singularity. We have one spot that is at that level. If we raise this up to around 2, you can see that inside of the pivots that are held fixed, that we have a higher stress concentration. This can be due to the method of attachment that was used in our constraints. So this doesn't necessarily tell the entire picture, but it does give us some idea as to changes to the design that we can potentially make, as well as things in the simulation study that can be reviewed. From here, the next step would be to finish the results and identify the constraints used in the load case, noting that these are fixed. Changing these from fixed to a pin constraint could potentially help the situation by identifying a proper loading condition. For this example, however, let's go ahead and save the design before moving on.